Good morning. My name is Lee Jin Yu, and my teammate is Tan Sing Fu. Today, we're going to discuss about simulation, credibility theory, computer-based exam. We're going to focus on one insurance sector, and we discuss and how we use our simulation inside. So we proceed. Okay, the thing we focus is the life insurance. First, we develop a simulation scenario by focusing on different interest rate and survival patterns of population. In here, we create a 10-year term life insurance and simulate it by using a life table in Japan to access the change of interest rate to expected return on an insurance company financial performance. So we'll proceed. Okay, we'll discuss about the financial challenge of the change of interest rate. So the first one is we're using a live table to access the change of interest rate by affecting live table of Japan age 15 to 65, which purchased the term life insurance. So we can compute the company's financial by calculating the expected return and also the annual premium for the insurance company. The second one is annual premium and insurance payout death benefit during the coverage period by setting constant. There are three things we set it on constant. First one is sum assured. We set it on 100,000. Number of years of term life, we set it on 10 years. Number of insured tested, we use 100 policy holders to simulate the model. The third one is the simulation result us to make decision by choosing a right interest rate for the term life insurance by adjusting assumption based on the real world observations. So we can understand how actually the change of interest rate actually impacts the financial performance of the insurance company. So these are the steps. First one is the preparation of data. We have prepared a data of life table of Japan with combined sex during year 2022. The second one is change of variable. Our variable is change of interest rate. We set it on three interest rate, which is 4%, 5%, and 6%. So we have our scenario testing on three different interest rate. The fourth one is the claim processing by using the Excel. So later we'll demonstrate, Simply will demonstrate it on the Excel by calculating the payoff, annual premium, and also the expected return. So the fifth one is the financial impact. Actually, we calculate the expected return to actually see which interest rate is suitable for the insurance company to choose if they need to maximize their profit. Six is the decision making, and the last will be the reporting and conclusion, which is the summary. So this is the process. The first, we actually construct a live table for Japan combined sex. We Google it and find an example, and we compute into a 10-year term life insurance for age 15 to 65, which is the age range which purchase this 10-year term life insurance. Second, we mainly our aim is to find the annual premium and also the expected return with changes of interest rate for 100 policy holders with different age. The third one is we compute and find which is the suitable interest rate for the given data. And the fourth one will be we do simulation and lead to our decision making for making the 10-year term life insurance. The last will be conclusion and summary. So I will show you what we use in the data of Excel. The first one is the combined sex life table. We use the combined sex Japan for year 2022. As you can see from this, we have age, probability of death QX, probability of survival PX, life expectancy EX, expected X, probability of survival conditioner, and probability of death conditioner. So this is from age 0 to 110. So the next one we calculate is the payoff. Payoff is we need to find the present value by setting three constants as mentioned just now. The sum assured 100,000, number of term life insurance 10 years, and the age range from 15 to 65. So we can see actually we use the live table to calculate the 10-year present value from age 15 to age 65 here on the second side of the payoff. So we proceed with next. On the premium side, this is how we calculate the annual premium. So actually, we also stated from age 15 to 65. and we put probability of death and probability of survival, and later the more into the calculation will explain by Xingfu. So I just go through. So this is the premium for sum assured will be calculated for different ages. As you can see, the older the age, we can see the annual premium is higher. So we can see from the age 65, the annual premium is actually approximately 1,100. So this is the second aim, which is the expected return. We calculate on 3 different scenarios, 4%, 5%, and 6%. So actually, for the expected return, actually we are from the perspective of the insurance company. So we need to use the premium minus is sum assured, which is the claim by the insured. So we need to use the premium to deduct by the sum assured. So this is from the 4% interest rate from 100 policy holder at different by age. So we can see from 4%, the total return is 4,449. And the next scenario, which is 5%, and also by using the same way, just changing the interest rate, we can find the total return is 4,292.54. So the last scenario, which is the interest rate is 6%. By using the same way, just change the interest rate, we can find the total return of the insurance company by using the annual premium minus the sum assured will be 4,140.59.
All right, thank you, Jinyu, for explaining our entire simulation plan and results. Hello, everyone. I'm Xin Fu, and I'm also an actuarial student from Taylor's University. Next, I will share the steps and methodology of the entire simulation. Before we begin our simulation, we need to gather some historical data. So I have obtained the life table for Japan in the year of 2022. In this set of data, we can obtain the probability of death and the life expectancy. So the life expectancy is the number of the remaining years one can potentially survive. So next, after we getting the data, we need to construct the premiums using the financial concept to ensure the present value of expected future payouts is equals to the present value of the premium income. So this approach consider the time value of money, discounting future cash flow to their present value. Next, we look at the calculation of payoff for 10-year terms life insurance. So we need to calculate the expected payoff of each age within 10 years. Yeah, here's the 10 years. So the expected payoff is just a simple calculation. We look at the first year. It is the sum assured times with the probability of death if the person dies in the first year after purchasing the policy. So if the person dies in the second year, since he or she has survived for 1 year, we need to time the sum assured with the first year of the probability of survival and the second year of probability of death. If they die in the third year, the steps are similar except we need to time 1 more year of the probability of survival. For another seven years, we continue with the same pattern. So after calculating all payoffs of each year and each age, okay, so we need to discount them with the interest rate to calculate the present value of the date of policyholder purchase. So we can see that the interest rate is 0.05, and then here is the formula for the present value, which is the summation from 1 to 10, and this is the years, from year 1 to year 10, and we take out the each year of payout divide by the 1 plus I power of the each years. Okay, so after this step, we obtain the present value of expected payout of each age the policy holder purchased in the insurance. Yeah, so here got 50 years. Okay, so after that, we look at the table of premium for 10-year term life insurance. So when a policyholder purchase an insurance, right, they should pay a premium each year during the term of insurance. Hence, we need to calculate the present value of the probability of premium being paid so that we can construct the price of premium. So first, we need to calculate the probability of premium being paid by a policyholder. We know that a policyholder purchases insurance, the premium should be paid at the beginning of the year so that the insurance becomes effective, right? So the probability for the first year should be 1 because all the policyholder should pay the premium after they purchase the insurance, right? Okay, so in the second year, the policyholder has survived for 1 year. So the probability of paying premium equals to the probability of survival for 1 year. Yeah. Same with the third year, they have survived for 2 years. So the probability is the product of the 2 years probability of survival. So yeah, in the fourth year, we need to get the product of the 3 years probability of survival. Okay, after finish calculating each year probability, we need to discount them to get the present value. So here is the formula for getting the total present value of the probability of premium. So after getting the present value of probability of paying premium, we need to obtain a premium that should be paid for every year, right? So since the present value of premium should cover the present value of the expected payoff, the premium is calculated using the present value of payoff, which calculated before, and then divide by the present value of the probability premium. Yeah. So we will get like if we buy the policy at age 15, so each year we should pay 27 ringgit 31 cent of premium. Yeah. So after we get a premium table for the age from 15 to 65-year-olds, so we can start stimulate the expected return for the 10-year terms policy for the insurance companies. Yeah, we can see that this is the simulation part. So we randomly choose the 100 policy holders and calculate the 1-year expected return with 3 different interest rates, which is 0.04, 0.05, and 0.06. Okay, so here we simple calculate the one interest rate, which is 0.05. So to calculate the expected return, we need to take the total premium minus the total claims paid. So after that, we sum up all the expected return to determine the profit and loss. To compare the different interest rate, so we just to change the interest rate here to get the different profit and loss. Yeah. So lastly, we make a comparison with the different profit and loss to get the best interest rate. So here is the extra information for the notation here. So the notation is the formula, which is the summation from 0 to 1 because we just need to find the 1-year expected return. And then the VK plus 1 times with the KPX times with QX plus K. Yeah, the KPX is the probability of survival and the Q is the probability of death. Okay, same with this notation. The formula is just the VK times KPX. Okay. So after calculating all the expected returns, we sum up and we get the total return. So this total return is the profit and loss of the insurance company for the 1 year. Okay, so this is our model sharing, and I will end my presentation here. Thank you for watching and listening.
So it come to the decision making. So in the simulation test, we generally focus on the annual premium insured and expected return on different age buying the 10-year term life insurance, just like just now. like for first policyholder, actually you buy at age 23. We use the random generate for 15 from to 65. So both figures actually affect the financial performance of an insurance company, as insurance company seeks profit from annual premium. Mostly all the revenue generated by the insurance company is actually from the annual premium. So actually changes of interest rate generally become a great impact on giving extra opportunity to insurance company to get a greater profit. So by using a real world issue on different insurance company is on how they maximize their profit to further analyze on the life table is very important, because mainly revenue generated by insurance companies from the annual premium. So by changing the interest rate, we can know how interest rate actually impact the insurance company generating their revenue. So we'll come to the conclusion and summary. So first, the mortality table. With the mortality table, which is a life table, we can calculate the payoff, premium, and expected return of an insurance company by setting constant, number of year of term life, number of age range of policyholder, and the sum assured. The second one, from conducting the interest rate, we can know that actually the lower the interest rate, the greater the expected return, which on the 4%, which has the highest expected return. The third one, advanced analyze on the payoff, premium, and return to expected return actually configure the profit and loss of the insurance company. So the fourth one, increase in annual premium generally affect the revenue of the insurance company. So because I mentioned just now, mostly revenue generated by insurance company is from the annual premium. So the higher the annual premium, the insurance company can generate more revenue. So proceed next will be the simulation scenario we use. We set random on the age from 15 to 65 at the expected return side, so we can compute a different outcome. And the last one will be actually insurance company can construct their convenient interest rate evenly to get a greater revenue, so they can adjust which interest rate is much suitable and convenient to the policyholder in order to get a revenue, and also at the same time getting the same volume of sales on the policy. So this end of our presentation. Thank you.